United States Navy is now equipping fighting units of the fleet with one of the first digitally controlled gunfire control systems, Mark 86. Among the most advanced automated systems in the fleet, the Mark 86 uses real-time target data to control the 5-inch 54 caliber lightweight gun mount Mark 45 against surface, shore, and air targets. The number of guns and the particular version of the gunfire control system is determined by the ship's configuration and mission. Of the 3 models of the gunfire control system being deployed, we'll concentrate on Mark 86 Mod 3. We'll describe the system and its functions briefly, and then take you through short operational sequences to give you a better feel for the system you'll be learning about, the gunfire control system Mark 86 Mod 3. Details of the installation will vary, but in the DLGN 36, for example, Mark 86 includes these equipment groups. Externally, above-deck equipment of the sensor group includes 2 antennas, one for a surface radar SPQ-9 in a protective radome, the other for the air track radar SPG-60, and 2 television cameras of the remote optical sighting system. Internally, the display group includes the control officer console, referred to as COC, and 2 gun control consoles called GCCs, located in the weapons control area. Radar electronics of the sensor group and the equipments of the data processing group are distributed in 3 equipment rooms. Mark 45 gun mounts are fore and aft, controlled by the Mark 86. The air track radar must be designated or pointed toward specific targets so that they can be acquired and tracked. Designation can be internal when detection is by the system's own surface search radar or by its remote optical sighting system. More usually, designation comes from external sources, such as ship's radars or manned target designation transmitter and control unit positions called TDTs and CUs. TDTs and CUs are linked directly to Mark 86 data conversion equipment. All other external designations are processed by the Navy Tactical Data System and linked to the Mark 86 by computer-to-computer interface. We're mainly concerned with the gunfire control system, so let's now look at its equipments in more detail. Beginning with the sensors. The Surface Search Radar, SPQ-9, is the basis of the Mark 86 Track While Scan, or TWS, capability, and is used for surface and shore targets and air targets at low altitude. Scan rate is 60 RPM, or 1 revolution a second. In addition to the antenna, the surface radar includes a transmitter and a receiver unit, a frequency converter unit, and a video processor unit. Tracking during air action engagements is carried out by the Air Track Radar SPG-60, a pulse Doppler monopulse tracking radar whose antenna also mounts one of the remote optical sighting system TV cameras. Associated units include the transmitter, receiver, the antenna control, and a signal data converter. In addition to the TV camera on the air track antenna, the remote optical sighting system includes another TV camera mounted on its own pedestal, with full compensation for ship's motion provided by a gimbaled trunnion. The display group includes the control officer console, characterized by the PPI display, and 2 gun control consoles at left and right, incorporating TV video and B-scan displays. The sensor and display groups are supported by the data group, which includes a high-speed, general-purpose, stored program computer, an input-output console with hard copy printout capability, and units supporting data processing functions such as signal conversion and translation. In all, the gunfire control system Mark 86 Mod 3 consists of 23 operational units plus 1 spare storage cabinet. It all exists to provide automatic digital control over the rapid-fire 5-inch 54 caliber Mark 45 gun mount. The gunfire control system can operate in 5 tactical and 2 non-tactical modes. Tactical modes include surface radar, air action, grid, TDT, and optical. Non-tactical modes include navigation and test. Let's choose one of the tactical modes and follow it through in detail, the surface radar mode. The COC operator energizes the Mark 86 system, bringing the SPQ-9 radar up to the radiate level. He detects a target, checks it out with CIC. He's ordered to engage. He does this by selecting an available track while scan channel. To acquire the target, he depresses the acquisition clear switch to acquisition. This produces a hook symbol on the display. Manipulating the trackball, he positions the symbol over the target. And, using the ball enter push button, he enters target coordinates into the computer. The computer commands first an acquisition, then a maneuver, and finally a track gate around the target. As the target is tracked, its coordinates are entered automatically into the computer and are continuously updated for use in the ballistic solution. This data is also used to position a remote optical sight to the target area for visual monitoring. To monitor the track, the operator switches the target data readout to TWS Channel 1. This brings up target range, bearing, course, and speed. The operator assigns the target to one of the gun control consoles, number 1 in this case, by moving its assignment switch to TWS Channel 1. He also checks indicators showing gun mount status. Gun standby is lighted. To determine proper gun assignment, he presses and holds the arc of fire switch. This brings up a display of the firing sectors for forward and aft guns. The gun that includes the target in its sector is the one assigned. By pressing the Gun Assign Normal switch, Mount 51 in this case. To follow what happens when the gun control console is assigned, let's first assume that the GCC operator has his part of the system up and ready to go. One of his standard duties is to enter mission data at a time determined by ship's doctrine. To enter wind direction, for example, he first presses the wind direction push button and checks the target readout display for the direction currently stored in the computer. If it does not match the actual direction, he first clears the data display, and then he uses the keyboard to enter the correct wind direction as indicated by meteorology reports. By depressing the Enter push button, the data is then stored in the computer memory. By depressing the Retrieve push button, he confirms that the new value is stored in computer memory. By similar means, he enters ballistic and ammunition factors of consequence to the ballistic solution for the approaching mission. Picking up on the surface radar mode problem we were following, gun control console displays are dark, and the operator has no control capability until the COC operator makes his assignment. This immediately activates the GCC console. This brings up Surface Search Radar target video, and he confirms that the target is centered in the track gate. He also checks his target data readouts for target parameters. And observes the gun mount assigned. The COC operator now is advised that GCC is ready to continue the mission. He depresses GCC 1 Enable, in effect giving that console the capability to take control of the assigned weapon. The GCC operator sees this indication at his console as single load and continuous load go red. The GCC operator verifies that the ballistic solution indicator is green, indicating the computer has completed its firing problem computations and gun orders are ready. He now changes director control to green, in effect slaving the assigned gun mount to computer-commanded gun orders. The gun slews to the commanded train and elevation. When the mount is automatically following computer commands, gun sync goes green. The operator selects single load, and ready to fire goes green, meaning the gun mount is set for the fire mission. The operator hits salvo warn, warning all personnel of impending gun firing. Then presses the foot fire switch. While ship's doctrine might call for a salvo of several rounds before entering a spot correction, we're using a single round to show what happens at the GCC console. Mark 86 continues to track the target during the round's time of flight. And 5 seconds before impact, an impact warning indicator comes on, so that the operator knows when to watch for the fall of the shot, marked by the shell splash radar return. Assuming a round falling wide by 20 mils, the operator marks the impact position. To correct the gun order by that amount, the operator presses the spot button and uses the joystick to relocate a video spot from the center of the display to the marked shell splash position. He enters the correction into the computer by pressing stick enter. The spot returns to the center, and gun orders have been corrected accordingly, as confirmed by the spot corrected indicator. With gun indicators showing the mount is synchronized and ready, the operator selects continuous load and again fires. This time, the target return disappears. The operator presses Target Kill to inform NTDS via the computer that the target has been destroyed and sounds the ceasefire to complete the mission. There are times in problems like the one we've just seen when 2 or more targets are included in the B-scan tracking gate. The system can't automatically select which is the target of interest, so the situation calls for aided track. The operator first goes to track coast, meaning that automatic tracking is discontinued. He then selects aided track, activating the joystick. He uses the joystick to move the spot to the target of interest, and uses stick enter to enter those coordinates into the computer. This places a maneuver gate around the selected target. Pushing stick enter again closes it down to the track gate, refining the area containing the target to 120 yards by 26 mils. This clearly defines the target of interest to the system. And when track coast is released, the computer resumes automatic tracking. To deal with targets aloft, the Mark 86 provides the air action mode. Tracking is by the air track radar SPG-60 under computer control. The radar is directed either by the self-designators of the Mark 86, including the Surface Search Radar SPQ-9, the remote optical sight on the air track radar, or when this radar is operating in the automatic search mode producing a horizon scan. Or it must be directed by external designators, such as the target designation transmitters and control units, or NTDS, using inputs from ship's radars and other units of the fleet. Let's assume designation by NTDS. The operator at the control officer console makes the console assignment by switching the GCC2 assign to air action and designator select to NTDS. At GCC2 console, the operator enables automatic acquisition and track by the SPG-60 radar by placing both azimuth and elevation in automatic. He also selects the comb filter display, which shows acquisition range gates. The tracking radar is now computer controlled, and its functions are wholly automated. At target acquisition, and then at track, the acquisition and the track indicators light up automatically. Because SPG-60 is a pulse Doppler monopulse radar, the operator listens to Doppler audio to monitor the quality of the track. If a zero Doppler condition is experienced, the operator has controls available to assist the track using the fixed target lock-on method. This complements the automatic coast mode or manually selected forced track coast. As soon as the ballistic solution indicator lights, he fires as before. We've watched Mark 86 in action in surface radar and air action modes. So now let's go on to the modes related to gunfire support using the three sub-modes of the grid mode: dead reckon, beacon, and navigational reference. In the dead reckon sub-mode, the computer controls the solution based on pre-planned position inputs. Let's assume a target on the beach visible both to the ship and to an observer who has radio contact with the ship's CIC. Advanced planning, using Universal Transverse Mercator or other charts, has pinpointed the target, the observer, and the point where the ship will be when the mission is scheduled to begin. The coordinates may all be entered into the computer in advance of the mission. As mission time approaches, the COC operator places a GCC console in the grid mode, using the GCC assign control and selecting Grid Dead Reckon. While the COC operator monitors, the GCC operator sets up for the mission. To observe the target visually, the operator places the remote optical sight in automatic mode, so it is controlled by the computer. The operator then enters meteorological, ballistic, and ammunition data using the keyboard as before. And using data supplied by CIC through the COC operator, he enters factors related to predicting own ship position, the target coordinates, and the bearing from the observer to the target. Upon arriving at the predicted own ship coordinates, the operator presses Dead Reckon. From that moment on, own ship position is continuously derived and automatically updated by the computer, using the ship's electromechanical log and gyro as inputs. COC assigns a gun mount, and the GCC operator completes the firing sequence. If the first round is not on target, the observer calls in a spot correction as he sees it from his vantage point, and the Mark 86 computer automatically translates this to the ship's point of view to produce the corrected gun order. Using the information supplied by the observer on the beach, the GCC operator enters corrections in deflection, range, or elevation as required to complete the mission successfully. The situation is somewhat different in the beacon submode. The surface search radar is used to interrogate and track a beacon transponder at known coordinates. With previously inserted target data, the computer determines own ship position, and from that, the ballistic solution. Then the firing sequence is completed. In the navigational reference mode, the procedure is nearly identical except that the beacon is replaced by a landmark whose coordinates are known. It is then tracked by the surface search radar, and the mission is completed as in the beacon mode. There are two remaining tactical modes, TDT and optical. In the TDT mode, the target designation transmitter with its control unit is interfaced directly to the Mark 86. The operator tracks visually and transmits target bearing and elevation. The control unit operator sets in estimated range. Using these inputs, the ballistic solution is computed. In the optical mode, the remote optical sights 1 and 2, used frequently to support other modes, can also operate independently. The operator uses the joystick to scan. When he detects a target, he zooms in for a close-up, centers the target, depresses the Sight Angle Enter push button, and makes necessary keyboard entries while keeping the target centered. Mark 86 can also be used in non-tactical modes. In the navigation mode, the system uses the high accuracy of the surface search radar to detect navigational features and provide accurate range and bearing readouts. In the test mode, 9 independent test programs can be called up to check overall system-level functions of the Mark 86 system. Any one of these programs, designed to verify performance, can be selected at any time. It takes a while to explain each of the operating modes of the gunfire control system Mark 86. The striking thing is that once a mission has been assigned, it takes only seconds to complete. What's more, in the real-life tactical situation, multiple missions pile in simultaneously: surface, air action, gunfire support. Each gun control console being assigned a new mission the instant it's completed the previous assignment. Rapid action, interaction, and reaction by experienced operators interfacing with the completely automated, digitally controlled gunfire control system Mark 86 assure that this nation will get the protection we are all being trained to provide.